Let us now talk about advantages and disadvantages of doubly linked list over singly linked list. As we've discussed earlier, in a doubly linked list, we have reference or pointer to both next and previous. So the first advantage of doubly linked list is you can traverse in both the directions. Imagine a real world situation where you want to build a software or code for managing edit history in an editor or managing browser history in a browser. So how will you do it? See, when somebody visits a page, then the next page, then the next page, and if somebody wants to go back, and then forward, the person should be allowed to traverse in both the directions from every node, right? Or every page in browser history. And this is very much possible with doubly linked list. You have head, which is a current page of the browser, right? And if you want to go back, you can go back. And if you want to go forward, you can go forward. So from any node, we can traverse in both the directions. We can go forward and we can go backward. That's one big advantage of doubly linked list over singly linked list. We can delete a given node in big O of one time. Suppose I am giving you reference to or pointer to this node and I ask you to delete this node. It's possible to delete this node in big O of one time in a doubly linked list. You can get the previous of this using previous reference or pointer. You can get the next of it using next reference or pointer. You can change the next of it and you can change the previous of it. And that's how this node is deleted in big O of one time. But if you talk about singly linked list and if I give you reference or pointer to this node 30 and if I ask you to delete it, it's not possible to delete in big O of one time. However, there are some tricky methods which allow us to delete in big O of one time, but those tricky methods also do not work for last node. The tricky method is, suppose I want to delete 30, it's a trick interview question as well. What I do is, I copy the next node's data 40 here, right? And then I delete the next of 30. So this way I am able to get the same effect as deleting the 30, but this is a tricky method and this method won't be able to delete the last node in a singly linked list. If I want to delete 40 in the singly linked list node, I do not have anything next, right? So I would not be able to copy anything data and I would not be able to delete the last node. Because to delete this node, I need to get hold of previous of it so that I can change next of previous, right? So it's not possible to write a general purpose function in a singly linked list that deletes a given node. The third advantage of doubly linked list is we can insert or delete before a given node in doubly linked list. For example, if I'm given this node 30, reference to this node or pointer to this node 30, and if I ask you insert a node 25 before it, it's possible. I can get hold of 20 using the previous pointer or reference. Then I can create a new node 25. I can change the next of 20 is 25. Then next of 25 is 30. Previous of 30 is 25 and previous of 25 is 20. It's possible in big O of one time. Similarly, I can delete the previous of 30 in big O of one time, right? I can get hold of this and I can get hold of this also, right? And then I can change the next of it. I can change the previous of it, and that's how I can delete also previous node. So insertion, deletion before a given node is allowed in big O of one time. See, in singly linked list, insertion, deletion after a given node is allowed in big O of one time, but not before, right? I can't delete the node before 20 or 30 because I can't go back, but in doubly linked list it's possible. The next advantage is we can insert, delete both ends in big O of one time. In singly linked list, if I have head reference or head pointer, I can insert here in big O of one time, I can delete from here in big O of one time. And if I maintain tail pointer or tail reference also, I can insert at the tail also in big O one time, but I cannot delete from the tail in big O one time, even if I maintain the tail pointer or tail reference. So if I maintain a tail here, and if I want to delete the last node, it's not possible because to delete the last node, I need to get hold of second last node. So in singly linked list, we can do insert at the begin, delete from the begin, insert at the end, all these three operations in big O of one time by maintaining two variables head and tail. But in doubly linked list, we can do all four operations in big O of one time by maintaining head and tail. And this is a big advantage of doubly linked list over singly linked list. There is a data structure called def or doubly ended queue or also sometimes pronounced as DQ. This data structure is a data structure that allows you to insert and delete at both the ends. And this is available in most of the programming languages. Python has a DAG, Java has a DAG, C++ also has a DAG. and that can be easily implemented using doubly linked list by maintaining two pointers or two references hand in hand. Let's now talk about disadvantages of doubly linked list. The first disadvantage is we need to have extra space for previous. See, in singly linked list, we have to use extra space only for next pointer or reference. But in doubly linked list, with every node, we have two things, previous and next, that requires extra space for doubly linked list nodes. Right? So if you have, say, 1 lakh items, then you are going to use 1 lakh into 2 extra space for next and previous. But here you have 1 lakh into 1 extra space. Right? The second thing is code becomes complex. So when you are doing operations on a singly linked list, you just need to maintain one next variable or next reference or pointer. But in doubly linked list, whenever you do insertion, deletion, or whatever you do a reverse. In everywhere, you need to ensure that next and previous both are maintained properly. So these are the advantages and disadvantages. This is simpler data structure with less functionality. This is slightly more complex data structure with next and previous, but with many more functionalities.